or good evening, I should say. So thank you for sticking with the talk track this afternoon. So it's been a long afternoon for many. So I'm at the end of the day. So I hope you can continue with us. So it's a little bit different to the maybe some of the other sessions we've had today. So I really want us to start thinking about our data. As data professionals, it's all about how we manage our data, and it's in our job title, you know. So our key message should be around data and our management and our security of that. So that's what we're going to be talking about this afternoon. And the title, Guardians of the Data. So if you enjoyed the Guardians of the Galaxy films and looking forward to Guardians of the Galaxy 3, you're going to enjoy some of the slides because I've got lots of images there to keep this a bit interesting. So protecting Oracle backups and ransomware for malicious intent. So that's the topic for this afternoon. So that's me, Ron Ekins. So I work in the office of the CTO at Pure Storage. I'm a principal solution architect there. I've been there for 5 years. There's my Twitter handle at Ron Ekins. I have a very active blog, ronekins.com. I also have a Git repository where I put Terraform and Ansible scripts and other things there, which you may want to check out. Cloud and enterprise architect, also an Oracle ACE director, like a lot of the speakers this afternoon. I guess from a data point of view, you know, I've been using Oracle databases since the mid-90s, and I've been working in the aerospace and defense industries, where data management and data handling requirements have always been top of mind. I've got a couple of pending patents on about how we should be managing our data. So what do we want to talk about, you know, and here's my agenda. So what are malware and ransomware? So let's make sure we understand these terms and how they're slightly different. Then I guess, you know, what can we do about this? Think defense in depth. What measures should we put in place to protect our data and our backups? And then some of the practical steps we can take to protect from ransomware and malicious intent. So when I say malicious intent, I mean a rogue system administrator, rogue DBA, bad actor sometimes is the term, someone that is causing damage. Maybe they have been told that their job's at risk. Or they didn't get a promotion and they're trying to cause harm. So that's what we mean by malicious intent. And then finally, what else? What else can we do? Does that sound fine? Okay. Please put your hand up, put a chat box up if you have any questions. We'll, at the end of the day, we'll try and keep this one moving on at a good pace and but build questions, so rather than wait to the end. So what are malware and ransomware? So malware. So this is a definition by the National Security Center. It says malware is malicious software which, if able to run, can cause harm in many ways, including causing a device to be unusable, stealing, deleting, or encrypting data. And I guess as data professionals, really that's what we're focused on. But it's also not that. Just that, you know, it can be taking control of your devices, your servers, to attack another organization. So maybe you have a network which a network on the defense side which lets you talk to other defense contractors, or maybe financial institutions which exchange data between other financial institutions. So you can use one company to attack another. Obtaining credentials which allow you to access your organization's systems or services that you use. So this is often what we think of malware, something that sits on your server and it's looking at the environment to cause harm. And, you know, using services that may cost you money. So this could be making phone calls, could be sending out emails. You could actually be doing business transactions that's causing your organization harm. So maybe they're not destroying data, maybe they're just piggybacking on your infrastructure. And finally, one that I guess which has become more common, mining cryptocurrency. So stealing compute cycles, whether that be in your data center or in your cloud, you know, so getting their mining for free. So lots of different ways we see malicious software being used. So how's ransomware different? So ransomware is a special type of software. So the definition here is the noun, ransomware, a type of malicious software designed to block access to a computer system until a sum of money is paid. So we're used to ransoms for people being kidnapped, or you have to pay money to get your loved one back. And it's the same. The loved one here is data rather than a person. So someone locks your data away, and if you want that data back, you have to pay. Or another definition could be a problem requiring unplanned DBA and sysadmin time to restore a massive amount of data. If you're in a ransomware attack, you really you've got pain, and you have to decide what to do. Ransomware. It's a type of malware, so it's a subsection of malware. So ransomware is a type of malware that prevents you accessing your computer or data stored on it. The computer itself may be locked, or the data stolen, deleted, encrypted. Most often now, when we talk about ransomware, we're talking about data encryption. A few years ago, we would have been talking about data theft, and that still happens. Someone can steal your data and then phone you up saying, I've got a list of all of your customers. I've got a list of all of your clients. And if you don't pay me money, I'm going to release that. And then your business will no longer be viable. People have no confidence in you. If you're an insurance company and all your customer details ended up on the internet, you would lose business. But that takes time. That takes a lot of energy to actually steal data. Encryption is a lot simpler because they don't have to actually move the data. They don't have to download it. They can do it in situ. Ransomware and malware, they like to propagate. So once you're in an organization, they will try to spread to other machines. And over the last few years, we've seen different ransomware attacks. And I guess one that's probably hit the everyone's consciousness was the WannaCry malware attack, which started in one point of the globe in the US and spread rapidly across all countries and all boundaries. As companies are interconnected, countries interconnected via the internet, it makes the transmission of a WannaCry malware or other sort of very simple. And you don't need to be a computer expert to generate ransomware. The term RAS, ransomware kits, so ransom as a service, is something which we're talking about now. We talk about IaaS, infrastructure as a service, software as a service, ransomware as a service, which is a very frightening thought. So without any computer skills, you can now buy a service. You can go to a website and run applications which generate a ransomware kit for you. So you say how much you want to charge, what encryption you'd like to use, and what message you want to put this. So this is completely automated. The people that develop these, they make money out of this. So you can go to the internet, you can download a RAS kit, and you decide who you want to attack, what fee that they should pay. Instructions are there, it's fully documented. You say minimal computer skills. The person that creates the RAS kit, they normally expect to get money from this. So they say the model could be the user that's doing the attack gets 80% and the author of the kit takes 20%. But depending on the complexity and the options in the ransomware as a service offer, they may change that so that maybe they take a greater percentage. Different prices, different ranges, very configurable. So you've been hit. It's the modern day blue screen of death. So here's a screenshot here of Deutsche Bahn train timetable. So all their timetables got hit. So very much customer facing system, very dependent, all of the trains delayed. So what do? They have to make a decision. How do they pay their cost? This is a little screen that you can see, a pop-up, and it will say how much to pay. Normally the payment is via Bitcoin because hard to trace, but it will give you a time of when you need to do this by. Then it's pay and cross your fingers that they can recover the data for you. But it's not just big organizations and national infrastructure that get attacked. You know, Bangkok Airways earlier in the year, a train network in the UK, its ticketing systems taken down because they've been attacked. So they had to take the service away, could not do any new transactions until they cleaned up all their infrastructure. And you think, well, these are commercial organizations, they should know better. Nobody's going to attack a school. But that's happening as well. We had a school in the UK that because of COVID and people working from home and also children studying from home, that was a good target for a ransomware. So the school was unable to pass exam results to universities, and they was unable to conduct any lessons because all of the syllabus, all the materials was online. So that was so the school had to decide whether they wanted to pay or not. So primary schools, secondary schools, all academic environments are vulnerable to this as well. And one thing you think that we would all avoid, even healthcare. So even though all these organizations that are trying to save our lives from COVID, we're seeing ransomware attacks in the medical research departments. So anyone is vulnerable, any industry, any country. That's ransomware. But when we're looking at ransomware, we're not just talking about our production databases. The hackers are now hunting for your backups because they know that if you've got a good backup, maybe you won't pay the bill because you'll just go to last night's backup. So they want to make sure that you haven't got any backups that you can go back to. So that you need a backup of your data and you need a backup of a clean server. And this is actually a good point for infrastructure as a service. So if you need to build your server, you can build this quickly without having to maybe do a restore of an image and go back to a clean image. So you can actually generate a server. But if you've got an application which is been around for a long time, maybe it's not that easy to create that infrastructure as a service build. But hackers spend a lot of time understanding our solutions. The average time that we talk about is over 200 days on a network. So once that system's been compromised, they can spend up to 200 days or more looking at that platform, understanding what servers you have, what file shares you have, where's your databases, where do you send your backups, trying to get a picture of the organization, where's all the data. Looking for your production databases, looking for all the copies of your data. So this is what an attack could look like. So day zero, the hacker gets access to your system. And this could be the fact that someone's clicked on an email. They haven't followed company process, or they found a USB stick and they've stuck it in a machine, or someone has deliberately brought in a bit of malware, or they visited a web page. So there's lots of ways that we can be made vulnerable to a phishing email or an exploit in a system. So the attacker is on our platform. What do? Well, they find critical applications, databases, accounts, and file systems. And they can spend quite a bit of time doing this, looking for our system. Then they decide to start encrypting the data. At this point, we've got problems. The data is encrypted. They may start deleting our backups, erasing snapshots, and removing all our protection. Then we get that phone call saying, pay up if you want your data unencrypted. So we've got some challenges now. We've got no good data, and we haven't been looking after our backups securely. So they've deleted our backups. So we're going to have to decide whether we're going to pay or not. Pay and pray. Soon after, we make a decision, we're not going to pay, then we do some recovery, we begin patching, and we see whether that recovery points objective is satisfied. Can we actually afford the business to go back? If we can, we may decide to roll back 2 weeks. We may decide to go back 2 months, or pay the bill if we can't live with that. But backups are our last line of defense. So our production database has been encrypted, or the data. What do? So if our data is encrypted, it's backups or pay and pray. And the payment is always time-based. So they would actually increase the cost if you don't do it in a timely manner. Or say, well, the encryption key, there it is, and then you pay it and it doesn't work, and you may have to pay more. Doesn't mean they won't keep coming back. So what can we do? We got to think defense in depth. Think of it as an onion. So working in secure environments for a number of years, say since the mid-90s, we start with policies, procedures, and awareness. Then we think about physical security. Building on top of that, network security, host-based security, application security, and at the heart, what everyone is after, data security. So think of that picture on your head, and then we can start developing solutions. So this isn't just a DBA issue. We've got to talk to the application team, we've got to talk to the network team, the storage team, and the infrastructure teams to make sure that we're all working to the latest security patches and are aware of any vulnerabilities. So, policies, procedures, and awareness. What do we mean by that? So start with employees and contractors. So this could be, as someone comes into the company, you have a vetting system. So you try to make sure that you don't hire someone maybe that has issues with financial challenges, where they could be compromised, where they make it or may have a drugs issue, where you have vulnerabilities which could be exploited. So you would do something for me, I give you this money, you let me in the back door, you put this on the computer. So you start with vetting, making sure that people are as best you can of good nature. You use training and education, teach your staff permanently to not click on email links. Think about the way we work, think about the way we handle our data. Treat it with white gloves, treat it as if it's your data, not the company data. We wouldn't leave our bank card and our PIN number in a pub on a table. We've got to treat the data the same way, our company data, as if it's our own. Think about site security. This could be security guards, it could be guard dogs, it could be fences, it could be security zones and doors and keypad access. So lots of organizations have this. So we've had these in place to make sure that we know who goes into our data centers or into our offices. What we don't want is someone being able to walk into an office and put a USB stick in the back of a computer and then walk away. That could be a cleaner, contractor. So we have to have access. We want to know who's on our site when. If someone comes into a building late at night, why are they doing that? If someone comes onto our network late at night, is that an unusual way of working? Have they been compromised? How are they working correctly? Or is this something that's malicious that's going on? But it's a lot more complex now. The network security now has to include remote working and remote access. Maybe we have to teach our staff and re-educate them that they should be doing remote access in their home office rather than in a shared space in a coffee shop. If they are they doing this over VPN? Have they got people looking over their shoulder, watching their keystrokes? In the same way that you would shield your PIN number when you make a payment or a cash point, you want to make sure that no one's watching what you're doing when you're working remotely. So they're more the sort of the practical side. So what do we do within the data center? What can we do as DBAs and database professionals? Think about our host security, hardened servers. And what I mean here is, and this is where infrastructure as a services really can help you, is you only install the necessary applications. If you've done installs before, maybe you've taken an ISO image and you've just said full or internet or developer, and it's got applications on there, you don't know what they are and you don't know if you need them. So we start uninstalling those. So only have the necessary applications. Apply latest security patches. Only run the required services. So if you don't need an FTP server, don't have the FTP service running, uninstall it. Only run tools and applications from trusted sources. So we've very much in the last few years, we've got used to the idea of taking stuff from a GitHub repository. And that's great if you're taking YAML files and Terraform files, which you can look at. But if you're taking binaries, you know the source of that binary. So make sure that when you take binary images that you actually know where they've come from. Or if you're taking a Python script, you're able to read the Python script to know what it does. Things get changed in GitHub repositories, and you don't know sometimes where that original source came from. So if you're taking an Oracle binary, only take it from the Oracle site. Don't take a Docker image that someone's built for you, because you don't know what else they've included in that image. Application security, the same. You look at the applications, know the application's vulnerabilities. If you're running something like Oracle E-Business Suite, make sure you're fully patched. You're taking the latest security patches, latest database patches. Think about the way we think of and secure applications. Use the mindset of least access needed to do your job. So you don't give someone root if they don't need root. You don't give someone the Oracle account. Log on as a named user, then use sudo to the commands they need. So lock the system down, lock the applications down to the minimal access they need to do their job. Data security, know where all your data is. Know where your production data is. So if you're doing database clones, understand where they're going. Are they going into a development server? Are they going to a test server? Are they going into the cloud? If they're going into cloud, which cloud? Who has access to them? How often are your development and test databases refreshed? If you were going to steal data, would you steal it from the production system, or could you steal it from a clone that was produced daily? Well, maybe the daily clone is equally as valuable. If you're not masking the data, you're not obfuscating it, you need to be thinking about where all your data is. Understand where your backups are. Are your backups in the data center? Are they being replicated to another data center? Are they in the cloud? Are you still going to tape? Are you putting them in something like Iron Mountain and locking them in a safe somewhere? Things that we can use to help us there is implement a SIEM, security information and event management solution, such as Splunk, which can help us collect logs and access logs, look for unusual access, unusual ways of working, security issues, and use the reports there to help us analyze that. So that's something we can do when you can think of the bets in depth. We need to think about our servers, we need to think about our data, but what about our Oracle database backups? So what we're trying to do here, we want to protect these from human error, could be accidental, malware, or malicious intent. So first, I would say, if you don't know whether you've got them or not, speak to your storage administrator. Utilize your primary storage snapshots. So this gives us that instant recovery. A storage snapshot provides instant point-in-time recoveries. There's nothing faster than using a storage snapshot. We can just roll back the database, roll back the application to a point in time. Snapshots read-only, therefore it's immutable. So that's great. We can actually protect that. And if we have regular snapshots, we've been told that our data set's been encrypted, maybe we can go back in time. Maybe that's good enough if we've got enough snapshots. Nothing faster than a metadata operation, pure metadata operation. So start thinking about your backups. You've got your RMAN backups. So I'd always advise people when they're doing RMAN backups to have those off array. So you don't want your backup and your data on the same storage platform. If that primary storage platform goes, and they're highly available modern storage platforms, but they can fail, and you only have all your data and all your backups in that one place, maybe you've lost your data and your backups. So think about where your backups are going. And one way of protecting your database is using RMAN with NFS. Oracle's direct NFS is very powerful. It allows for great scalability and throughput. So you have your production database servers and you have an NFS filer that you're going to be backing up to. So let's try and say we want to make it as hard as possible. So someone compromises our platform, we don't want to make it easy for them. So they can see that there's a database, but they can't find our backup. So we can make that a bit harder by using AutoFS. So hide our backup location from the NFS. So if they did a df-h, they wouldn't see the backups. I've got a blog post there. So Auto Mounter, AutoFS, really easy to install. So install it with sudo yum install AutoFS if you use yum or RPM. Once you have it installed, you need to configure it. So you start by creating an Auto Mounter map, which describes the file system that you want to map automatically. We create the map file, and then we start the service. So now we have this in place. Rather than having my mount points mounted every time I start the server, or I do a mount -a, and have them in the FS tab file, which you can be seen, we make it a little bit trickier. So if I have a file here, so I'll put my database server, I'm using a AutoFS file, .autofs. I can set a share directory there, so mount all the backups, and then a timeout. The default is 5 minutes in activity. I've taken this down to 3 minutes. So after 3 minutes, if this directory has no more reads or writes going to it, it will unmount. So this is my auto.fbnfs file. So that's the extension I give them that. I'll set my 2 databases here. So I've said the type, it's going to be NFS, some mount rules, and then there's the filer, so where it's been exported to, and the share names. So I've got 2 directories which can be mounted when I need them. So on my database server, I do a df-h. If you want to see type NFS, so it's only giving the NFS mount points. And I've got no backup directories here. And maybe if I'm looking at your system, I will say, oh, there's no backups here, and I'll move on. I'm going to prioritize my days that I'm on your system. Or my script isn't going to discover an NFS directory. It's only going to come back with those directories and see that there's no backup locations. So I've got a bit of knowledge, and I cd to root and say, oh, lots of DBAs mount their backups under mount directory. So I cd to mount, and I see a directory called Ola backup. So I cd to Ola backup, and I do an ls -la. Oh, there's no backup files there. I move on. So that's like, well, there's no backup files there. Where are the backup files? When I know the database name, in this class demo, I cd to demo, and then I can do an ls, and all my data files are there. So it only gets mounted and the data files become visible when I navigate into that directory. So a great way of making it a bit harder. So now I've had to know where the backups could be going, and I also need to know the database name to find those backups. And if I then do a df-h, again with the type NFS, you can see my backup file system has been mounted, mount or backup / demo. So I've mounted that on demand. And if I don't do any more activity there, that will then automatically unmount after 3 minutes. So primary storage, we do our database servers through a NFS, DNFS style backup, and we've got those on our NFS server, which is great. So we've now got our database backups off array. So we have, if our production server got compromised, we still have a good set of backups in a secondary platform. So we need to think about how we can protect our backups. So on our NFS server, utilize storage snapshots there as well. So take an NFS file system snapshot, so another immutable snapshot of your RMAN backup locations. Which is good. Now we've got a read-only version of our backups. So whether that be a policy in RMAN that says remove backups, or accidentally you're in the wrong directory and you say delete backups, or someone is trying to destroy your backups, we've got that read-only version of those which can't be removed. We can automate this. We want to make things repeatable, so we'll make it easy as possible. So I've got a Python script. So most storage platforms have, modern storage platforms have a software development kit, command line interface, so APIs that you can develop the ability to take snapshots, because you don't want to be taking snapshots during your, manually have to go on there and take a snapshot after every backup. So you want to have that as part of your backup script. So you take your existing RMAN backup script, and then after the backup's finished, before it the script ends, take a snapshot. So here I've got take snapshot, and that's in my repository. Very easy. I'm using a software development kit, so it's a very few lines of code. Automate everything. Use DevOps tools. If you don't use Python, You could use curl to use a REST API. You could use Java or any other modern language, or even Bash to use a REST API call. So I've taken my storage snapshot on the file system. So this is the scripts. So it's a Python script. So I have some command line parameters that I can pass to it. So the name of the array, the share, I can actually replicate it. So I can take a snapshot and say replicate that snapshot to another NFS server. So I have it on the primary array, on the secondary array, and on a third array. That's an optional switch. So it creates me a snapshot. So now I have a read-only snapshot of my RMAN backup. So if I do incremental merge every day, I can still go back to last night's one because I've got that snapshot of that one, which is really good. So that's another bonus. We haven't just protected our snapshots. We can actually go back to a full copy yesterday, full copy a day before, and go back as far as we like if we have those snapshots in place. So we have our snapshots. Something that you might not have used before, and it can be really handy if you think about, you're protecting your snapshots. So we have our database, and we want to do a restore. So we can snapshots, we can roll back, we can restore to a .snapshot directory, we can file copy out of there. But what if we just want to use them as a standard directory, because they are just file systems? So we can use the RMAN catalog start with, specify our snapshot directory, no prompt, and then this uses a wildcard, and you can then add all of the data files that it sees in that directory to our RMAN catalog. So here I'm saying search my .snapshot directory for all my backups. So it looks at that pattern and finds all of these backup files and adds those to my RMAN catalog. Great. So now I have an RMAN catalog which is being maintained by Oracle, and if it deletes the backup, from a policy point of view, it will delete it from other backup demo, but it won't touch the .snapshot directory. I have a version sitting there. I can check that my backups are good. So there's no point doing backups if your backups don't work. You should be testing them periodically. But we can use the restore database validate to make sure we can read them okay. So I can say, because it's added to my catalog, I can validate those. Restore database validate, and it will read the files from the .snapshot directory. I want to restore the database, so I don't actually have to copy the files out of the .snapshot directory. I can tell Oracle, restore database, but it's going to use here the RMAN.snapshot location and go back to my ASM demo database. So here I'm restoring the sales order entry table spaces from my backup from a .snapshot directory rather than my daily incremental backups. So now I've got a way of using my snapshots and having them integrated in my Oracle environment. The backups are only visible when I navigate into those directories because of the AutoFS. So I've made it a bit harder to find them, and I've also protected. So here we have our immutable snapshots, and because of my snapshots, the way I've taken my script, I can also replicate that snapshot to a third location. So this could be in the same data center. It could be in another data center. So now I have different backups in different locations. But what happens if our storage platform gets compromised? So we're protected now against DBA and sysadmin, because if they get onto our storage platform, they can try to encrypt the backups, they could try to delete the backups, and they can't do that because of the .snapshots. They're immutable, they can't destroy them. So they might say delete snapshot, and we can stop that. But what if someone has the permissions on the storage array to delete the snapshots? Well, that's what we need to protect against as well. So this is where you need to be speaking to your storage team, understand if they have the ability to lock down snapshots, to block the deletion of snapshots. So if you are a bit of malware software, you're going to try encrypt data, and then you're going to try and delete backups. If they see a snapshot, the APIs are there to delete the snapshot, so they delete the snapshot as well. Because we can take a snapshot through Python, I can delete a snapshot through Python. So that's one thing we need to protect against. And we want to protect our mutable snapshots and our RMAN backups. So whether this be policy, code or human. It's important that they're protected. This is where our safe mode snapshots come in. Snapshots stop the deletion of the backup. So we have now our snapshot, but even if the storage platform gets compromised and someone says delete snapshot, it will be blocked. This is a modern storage platforms have this as a feature. So it's definitely worth speaking to your storage platform. I know Pure Platform doesn't, so do others. If you delete the snapshot, rather than it being deleted after a period of time, some of them put it into a waste bin and then automatically delete in 24 hours, it will stop the deletion. The only way that snapshot can be deleted is if people's names that are on a support contract typically engage with the support team of the storage vendor who agrees that that snapshot can be removed. So now we have protection from rogue actor, malware, or policy mistakes. It's up here. It was a line that I got at POUG a couple of years ago, got a t-shirt with it on. Schroeder's backup. The condition of any backup is unknown until a restore is attempted. So we're taking our backups, make sure you know where they are, but also make sure that they work when you need them. So restore your backups, test them periodically, make sure that the process is working. Make sure that any production changes, infrastructure changes are reflected into your backup scripts. I've seen teams that have had backups failing for weeks and no one was declaring this the DBA team. So the administrator, sysadmin, and the backup administrator, they were happy for the backups to fail. They didn't have to report it. I've seen organizations where the backup's still running and the first thing someone does when the start of the business day is to delete the backups because they're impacting performance. So understand how your backups are working, whether they're fitting in the backup window, whether they're usable. So test you and restore your backups to make sure that when you need them, they're there. So are you ready for a ransomware attack? Summarize what we've just talked about. Understand the business impact and the requirements. Do you have a service level agreement with the business? How long have you got to restore the data? Do you have recovery time objectives, RTO? Do you have recovery point objectives? Do they meet the business expectations? Quite often I see that we've had SLAs that say, oh, we need to be able to clone a database in 2 weeks or restore a database in a day. But actually, if they had an incident, really, they say, we want it back now. They don't want to wait a day because our business has changed. It's more of a 24/7 operation. We have front-facing systems for our customers. We have internal systems with people working remotely around the globe. So our systems are always on. We need to make sure that our SLAs are aligned to the business. Understand application dependencies and database dependencies. Can you restore a single database application in isolation? If you restored the CRM database, did you have to restore the HR database and the ERP database? Are they related? If you had customers in one and you rolled that back and therefore in your accounts payable system, you had paid invoices and you restore that database with the customers in there and those customers no longer exist, but you paid them in your finance system, you're going to end up with data integrity issues. So you may have to restore more than one system to get it clean. It needs to be easy to follow. You need to know how long it takes. As soon as we're into a restore position where we're trying to recover our database from a ransomware attack, the first question you're going to get asked is how long? So if you practiced it, you know how long it's going to take. You don't want to be doing this for the first time, either because of a production issue or a malware issue. So know how long it takes, understand the steps, understand the system interdependencies, and review the procedures and runbooks with your peers. Work through them, test them, actually peer review the documentation and runbooks, whether these be automation scripts like a playbook from Ansible or a bash script or the documentation, the runbook procedures, and get someone else to test your process. If you do it yourself and you write it and you test it, you step over steps. You understand what you're trying to achieve. And if it's not there, you don't always realize that it's not there. Give it to someone else. Is it readable? Is it easy to follow? Can you give this to someone else? Because maybe you're not in work that day. Maybe you're on holiday, maybe you're sick. Can someone else do that restore without you? Have it so well defined that anyone in the organization could do that, that has the knowledge. The analogy I like to have is if you're working on a flight simulator, if you was a pilot. So pilots are heavily trained, and every year they're retested, and they have to maintain a certain number of flying hours. Maybe we should have DVA hours, but they do stuff in a simulator. As DBAs, we don't do enough stuff in the simulator. We should be testing our disaster recovery process. We should be testing scenarios. Can we restore a database? Can we guarantee that our backup's going to work? Do we know how long it's going to take? Do we know who we have to call? Think of the pilot. They go for all of these procedures and ways of working, but they still have a cockpit companion guide. So in the event of a disaster, the pilot has support. Here's his co-pilot, other members of the team in an IT world. He has someone on the radio, maybe Oracle support. For us, pilot is going to probably be speaking to either the manufacturer or the control tower. Depending on the nature of the problem. And finally, they have the companion guide, the run book, which details, in the event of a disaster, do this. You shouldn't have to think, you shouldn't have to be stressed by the situation in the event of a disaster. You should be trained enough, experienced enough, and have it well documented enough so that you know that if you need to, you can open that cockpit companion guide, and it's going to step you through the procedure. Yeah. So validate the backup scope and integrity. Perform regular restores and clones. Maintain the data recovery procedures. Document the approval and notifications. I've had discussions where people have said, yeah, we can do a restore in the morning. But actually, to get approval to do that, we have to go to our board of directors, and that can take days. Get that level of approval. So it goes to a manager, then a director, and then a senior director. And it takes a while for that to come through the organization. So understand how the approval chain is going to work. Who's going to give you the decision to fail over to a DR site? Who's going to give the approval to do a production restore? Simulate all the incidents. Know the what could go wrong and practice against those. Audit and test. Test and test and test. Documentation is critical to being successful. You need it to have it. You can hand it over to another person in the event that you're not being there. Simulate incidents and practice. Finally, last slide. Remember, protection needs a team. Data defense in depth, whether that be a network engineer, storage, Linux admin, application developer, SREs for automation, and DBAs. We all really need to work together in this. DevOps, infrastructure code really helps. DevOps has broken down lots of those barriers between operations and development. The developers know the applications, they know how it works, they know the dependencies. The network teams know the security. We need, as data professionals, to know what changes they're making. The Linux administrator needs to know what applications are running and what services are no longer required. Can we turn those off? Minimize the risk. As DBAs, we need to be on top of all the vulnerabilities that we're aware of. And if we do discover one, talk to our Linux administrator and network administrator and say, nobody has Telnet on a server anymore for good reasons, but there are other services. One thing I would always advise from a security point of view, it's the least information shared, is wherever you can, hide the operating system version. Don't give anyone any starters. Don't make it hard. So whether that be header information, database versions, OS versions, responding to ping requests, we need to protect our boundaries a lot better. So know who's in your team, know who the fellow guardians are, and keep your data safe. And that's me done. Adopt a multi-layered approach to data protection, giving ourselves the best chance of protection. Any questions?
Hello, Ron. It's Rodrigo speaking. Yeah, let me check if there are some questions. No. I think people are too shy today. Oh, there is one message here. Okay, not a question, just congratulations, super.
So it's a bit different than what we normally do in but I think it's such a hot topic at the moment. It's something, hopefully, we can go back to our day jobs and, think about what we're seeing and, what we can do to protect our environments. Speak to your storage administrator, speak to your Unix administrators, see if there's anything that they can do to make our databases safer. So AutoFS is a great one if you're using NFS. Storage snapshots, whether that be block to give you that instant point in time recovery, is something that we should definitely be speaking to our storage teams about. And if they're using NFS, can we use read-only snapshots to give us another layer of protection?
Yes, I worked in a customer last year. In the middle of the pandemic, they got all the databases, in fact, not all the database, but all the servers completely removed from one Solaris zone. Someone attacked one Solaris zone and removed all the things. The only good thing for the customer, the attacker was not aware about the devices. So as the data was stored in the ASM, it was easy to recover. So just a matter of reinstate the OSs and install everything, and then mount these groups again.
Yeah, so ASM does give us some protection.
Yes.
Because if someone has operating system skills, they can't navigate the database as easily. But if your backups are sitting on a file system, they can be vulnerable as well. So but if you're on your database server, so I always talk about TDE, and people say, well, I've got storage encryption, so I'm protected data at rest, and then I have TDE, so my database is encrypted. And if someone's on my database server and they do a strings attack, they can't see my data.
Yes,
right?
indeed.
But if they're on your database server, they're probably just going to log straight onto your database. If they're in a position where they can get onto your database server, there will be a vulnerability that lets them onto the Oracle account or to the root account. Then if they're onto the database and they're onto SQL Plus, the database is wide open. If it's the wallet's open, then they can look at the data. They can change it. They can encrypt it. So you can encrypt data at the block level. You can encrypt data through the database and for the file system. So if the device is there, ASM makes it harder, but we need to still think about our backups and where it's located.
It's not 100%, let's say.
But it's, as you say, it's all about making it harder,
Yes.
putting blocks in there, and that's the reason why we have pins on our cash point card. That's the reason we have locks on our doors. We're trying to delay stuff. It doesn't mean that someone won't get in your house or someone won't get into your bank account, but you're making it harder. And that's it. We've got to try and think of our data. What can we do to limit access to only the people that need to access that data?
Exactly, indeed. And also inside the database, we also need to do some protection. I see, since my entire career as a DBA, a lot of applications requiring DBA roles and other huge privileges. And for sure, there's no need of this. So
yeah, I think for lots of applications, it may be easier for homegrown systems where the developers are in charge. But many DBAs run third-party applications, and the application, when you install it, it says, I need these roles. And you go, do you really need all of these? Do you really execute anything? Do you really need?
Yeah, and if you don't grant those, the application even could make the installer happening. Yeah, it's because it checks the prehex, let's say. Yeah, true story. Sad but true.
Yes. Well, it's been lovely to spend the evening with you and the other people online, and it's my pleasure. So hopefully, maybe next year it'll be a in-person conference, and I'd love to come back and visit you all in Luxembourg. But if there's no other questions, I guess it's I'll leave it to you to round out the evening.